back to Fari's Educational Companion. Today I am going to discuss 10th grade mathematics. Lesson Trigonometry. Before going to start the lesson, let's recall the basics of triangles. As you know, triangle is a closed two-dimensional shape. It is a three-sided polygon. All sides are made of straight lines. The point where two straight lines join is called its vertex. Each vertex forms an angle. A triangle has three sides, three vertices and three angles. Let's have a look to the properties of triangles. An interior angle is an angle that we can find inside a triangle. If we extended the side length outwards, then it forms an exterior angle. A triangle has three interior angles and three exterior angles. Angle sum property of a triangle. Sum of the three angles of a triangle is always 180 degree. The exterior angle is equal to the sum of the two opposite interior angles, and also the sum of all the exterior angles of a triangle or any polygon will be 360 degree. We'll have a look of types of triangles. We can classify triangles based on their sides and angles. By classifying based on the sides, we have three types of triangles. Equilateral triangles, which has three equal sides. Isosceles triangles has two equal sides, and the scalene triangle has no equal sides. And by angle, we have three types of triangles. The first one is acute triangle, which has three angles less than 90 degree. Right angle triangle has one angle will be 90 degree, and obtuse triangle, which has one angle will be greater than 90 degree. Let's start the lesson trigonometry. In fact, trigonometry, as the name may suggest, it's all about triangles. More specifically, it is all about right angle triangles. Let's learn in detail. The concept of trigonometry was given by a Greek mathematician, Hippocrates. The word trigonometry is derived from Greek word. Tri meaning three, gon meaning sides, and metron meaning measures. It is the study of relationships between the sides and angles of a triangle. It helps us to work out missing or unknown side lengths or angles in a triangle. Do you know why do we need trigonometry? I'll explain with an example. Food production, that is agriculture, depended largely on the weather that you know. And a factor determining weather is the Earth's revolution around the Sun. To determine this correctly, we need to determine the position of planets and stars. So, astronomy plays a major role in the agricultural field. For that, mathematics, especially, we need geometry and trigonometry. In that way, trigonometry has a wide range of applications in real life. Let's see. It is used in navigation to locate directions and to pinpoint the locations. It's also used in flight engineering to calculate the height of buildings or mountains, and also used in satellite systems. Construction of maps describing light and sound waves, architecture and structural engineering, and in the medical field, computer graphics, even in computer games. It plays a major role. It has a wide range of applications in our real life. You can see the construction of one of the wonders of the world, Pyramid of Giza, applying the concept of trigonometry. Search and find out more real-life applications of trigonometry. In this chapter, we will study some ratios of the sides of a right triangle with respect to its acute angle. They are called trigonometric ratios of the angle. Let's consider a right angle triangle. The right angle is indicated by the little box in the corner. And the other angle is acute. The side opposite the right angle, which is the longest side, is called hypotenuse. The side opposite to the acute angle is called opposite. And the side next to the acute angle is called adjacent. Always remember, adjacent is always next to the angle and opposite is opposite to the angle. Do you know this philosopher? Pythagoras, a Greek philosopher who lived over 2500 years ago. He is credited with a number of important mathematical and scientific discoveries, most significant of which has become known as Pythagoras theorem. You have learned already. It is an important rule that applies only to right angle triangles. It says that the square on the hypotenuse is equal to the sum of the two squares on the other two sides. So, if we know the length of two sides of a triangle and we need to calculate the third, we can use Pythagoras theorem. You know how to find out or how to solve the problems using Pythagoras theorem. However, if we know only one side and one of the internal angles, then Pythagoras theorem is no use. So we need to use trigonometry. Here comes the importance of trigonometry. Let's start with trigonometric ratios. There are three basic functions in the trigonometry, each of which is one side of a right angle triangle divided by another. The three functions are sine, cosine and tangent, and their abbreviations are sine, cos and tan. Let's see how to calculate sine, cos and tangent. First we'll find out how to calculate sine. You can find sine by dividing opposite by hypotenuse. Easily we can remember it using the short form S or H. Sine is equal to opposite by hypotenuse. Let's see how to calculate cos. We can find cos by dividing adjacent with hypotenuse. Cos is equal to adjacent divided by hypotenuse. CAH, where C represent cos, A adjacent and H for hypotenuse. Is it easy, right? CAH, and we'll see how to calculate tan. We can find tan dividing opposite by adjacent. TOA. T for tan, O for opposite and A for adjacent. You may find it helpful to remember the trigonometric ratios as TOA, SO, CA by learning a funny mnemonic. The all archaeologists sat on his cot and hat. TOA, SO, CA. For a given angle theta, each ratio, no matter how big or small the triangle is, it will be always same. Now let's see the relation between sine, cos and tan. When we are dividing sine by cos, we will get sinus opposite by hypotenuse and cos adjacent by hypotenuse. When we dividing this, hypotenuse will get cancelled and will get opposite by adjacent. What is opposite by adjacent? This is nothing but tan. So, we will get sin theta by cos theta is equal to tan theta. This is our first trigonometric identity. We can learn it quickly using a triangular formula. Consider the triangle. You can represent sine, cos, tan inside the triangle like this. The horizontal line represents division and the into mark represents multiplication. If you want to find tan theta, then cover it and check the other quantities in the triangle. So, we will get tan theta is equal to sin theta divided by cos theta. And for finding sine, you just cover the sine, then you can see in the triangle that sin theta is equal to tan theta multiplied by cos theta. Now, can you tell me what is cos theta? Cos theta is equal to sin theta divided by tan theta. In this way, these three trigonometric ratios are connected to each other. Now, let us learn about some special right angle triangles. A special right triangle is a triangle with some regular features that makes calculation on the triangle is easier or for which simple formula exists. We have angle based right triangle and side based right triangle. Here we will consider angle based right triangles. We will see in detail. In any triangle, angles 30, 60, 90 degree, the sides are in the ratio 1 root 3 and 2. That means when you are considering any triangle with the angles 30, 60 and 90 degrees, always their side will be in the ratios 1 root 3 and 2. If the sides of any triangles of angles 45, 45 and 90 degree, then the ratio will be 1:1 root 2. Knowing the ratios of the angles or sides of these special triangles allows one to quickly calculate various lengths in geometric problems without resorting to more advanced methods. Let's do some problems related to this. Consider the first question. In the triangle shown, what is the perpendicular distance from the top vertex to the bottom side? What is the area of the triangle? By drawing the perpendicular from the top vertex to the base, we can split the triangle into two right triangles, ABD and ACD, as shown in the figure. From the figure, AB is equal to AC, and which will be 4 centimeter. And triangle ABC is an isosceles triangle. That means the three angles will be 180 degree. So ABD is equal to ACD is equal to 180 minus 120 divided by 2. That will be 30 degree. Now consider triangle ABD. You can see that here ADB is 90 degree. Therefore, BAD is equal to 180 minus 30 plus 90. You will get 60 degree. The sides of the right triangle with angles 30, 60, 90 degrees are proportional to the number 1, root 3 and 2. So we can write AD is to BD is to AB is equal to 1 is to root 3 is to 2. So from this, we will get the value of AB. AB is equal to 2x, which will be 4 centimeter, and x is 2 centimeter. AD is equal to 2 centimeter, and BD, it will be 2 root 3 centimeter. So what will be the area? Area is equal to B into H. It will be 4 root 2 centimeter square. From the top vertex to the bottom side is equal to AD, which will be 2 centimeter. BC is equal to 2 into BD, that is 4 root 3 centimeters. So what will be the area? Area is equal to half BH. It is half into 4 root 3 into 2, which will be 4 root 3 centimeter square. Hope you understand. We'll consider another problem. In each of the following parallelogram, find the distance between the top and the bottom side. Calculate area of the each parallelogram. So we'll consider the first parallelogram. Here 45 degree proportional to 45 degree and 90 degree. So it will be 1 root 2. So h will be root 2. So we can write area will be b into h, that is equal to 4 root 2 centimeter square. We'll consider the second parallelogram. Here it is 30 proportional to 60 proportional to 90. So the sides are 1 proportional to root 3 proportional to 2. So here h will be root 3. So we can calculate the area as BH. 4 multiplied by root 3, that is 4 root 3 centimeter square. Check the description box for the textual solution, and I have uploaded the same on my Facebook page too. Please go through it and comment for any doubts. So, we can conclude that the angles of a triangle determine the ratio of its sides. It is not easy in general to compute the ratios of sides from the angles. However, mathematicians from very early times have found a technique to compute such ratios for right triangles and arranged them in a special table. Let's have a look. Here you can see that tables of sine and cosine of angles differently by 1 degree. Let's look at a problem worked out using sine and cosine. Here you can see a figure. What is the area of this triangle? To calculate triangle, let's draw the perpendicular from A to BC. The area is half BC into AD, that is half 6 into AD, which will be 3 into AD. How do we find AD? From the right angle triangle ABD, AD is equal to AB into sine 50 degree. AB is 4, so it will be 4 sine 50 degree. From the table, we can get sine 50 degree, which is 0.7660. So, AD is equal to 4 into sine 50, that is 0.7660. It will be 3.064 centimeters. So, we can calculate the area. It is 3 into AD, that is 3 into 3.064, it will be 9.19 square centimeter. Thus, the area is approximately 9.19 square centimeters. Now, we will try textual exercise. Question number 1. The lengths of two sides of a triangle are 8 centimeter and 10 centimeters, and the angle between them is given as 40 degree. Calculate its area. What is the area of the triangle with sides of same length but angle between them 140 degree? Consider the figure. Area of the triangle is half into 10 into AD. Consider the triangle ABD. What is the sine value here? It is sine 40, which is AD by AB. Or we can write AD is equal to AB into sine 40. What is the value for sine 40? It is 0.6428 and AB is 8. So, it will be 8 multiplied by 0.6428. It will be 5.1424 centimeter. So, the area is half into 10 into AD and AD is 5.14. So, the answer is half into 10 into 5.14, it will be 25.7 centimeter squares. And it is given that if the angle between the side is 140 degree, then it will be sine 140. Sine 140 is equal to sine 180 minus 40. That is sine 40 only. The area of the triangle will be same. We will consider question number 2. The sides of a rhombus are 5 centimeters long and one of its angle is 100 centimeter. Compute its area. Here the rhombus ABCD we can construct as shown in the figure. It is a rhombus. From the rhombus, consider the triangle ABC. In the right triangle, triangle ABE, cos 40 will be AE divided by 5. So, AE will be 5 into cos 40, which is equal to 5 into 0.766. The answer will be 3.83 centimeter. Length of diagonal AC is equal to 2 into 3.83. It is 7.66. And cos 50 is equal to, from the figure we can write BE divided by 5, or BE is 5 multiplied by cos 50. It will be 5 multiplied by 0.6427, which will be 3.21. So, the length of the diagonal BD will be 2 into 3.21. It is 6.42 centimeter. Therefore, the area of the rhombus half D1 into D2. It is half 7.66 into 6.42. It will be 24.59 centimeter square. Click the link have given in the description box for the remaining textual problems, and I have uploaded the same on my Facebook page too. Now let's find out how